Today, I'm going to talk about transactional model for web services in service-oriented environment mostly, and then I will give you an introduction about digital business ecosystem and relationship between digital business ecosystem and service-oriented environment. First of all, in transactional world, we have at least first type of transactions that mostly you see them on database systems. There are transactions with 4 properties. They call it ACID properties, if you are familiar with ACID properties. Atomicity, consistency, isolation, durability. In business world, or in most of database-oriented applications, any action is supposed to have these 4 properties, because data has to be consistent during database application lifetime. It has to be atomic, which means a transaction has to be done completely or not being done at all. It cannot be something in the middle. It has to be consistent. That means an action will start when a transaction is in the correct state, in the right state, consistent state, and when the transaction finish, again the whole database will be in correct state. Isolation means when we have concurrency, that means so many transactions or different actions are running all together. For each transaction, it's more like this delusion that I'm the only one. Nobody else are touching these data. A database system is supposed to provide this delusion. Durability, that means with accidents, your data and result of these transactions are not going to be destroyed. You have backup system, for example. Okay, these ACID type transactions are great, but they cannot be applied everywhere. There are lots of places that they will not be applied, and we cannot use them because there are problems that I'm going to talk about it. Let's go to service-oriented computing and see the situation in service-oriented computing very briefly, because you have the course of service-oriented computing. I'm not going to talk about it a lot. Service-oriented computing is mostly about loosely coupling. You have location transparency. You have lots of services that they can have the composition, and you have lots of facilities in terms of different loosely coupled services provided by multi-participants. These are the problems that mostly we have with conventional transactions, with normal transaction, at least in service-oriented computing, but it is in any distributed systems. It's not just in service-oriented computing. First, and the most important one, is long life transactions. The transactions that have really, really long time, their lifetime is really long. With conventional model, for applying ACID properties, we used to lock the data, keep them safe, and run the transaction. With these long-life transactions, if you lock the data, they will be locked for a very long time. First of all, the whole performance of the system or environment here will be terrible. because everybody is waiting for that particular transaction to finish. Second, the probability for deadlock, that everybody is waiting for somebody and somebody is waiting for another person, will be increased badly. That's why this is the real problem. We cannot apply ACID properties directly in such a big service-oriented computing environment. Partial results. This, again, important business transaction is going to be run. There is a little bit problem somewhere, or that's omitted result actually. There is a little bit problem somewhere, and we have to do something about it. Based on the ACID properties, atomicity, we cannot wait in the middle. We have to undo everything. Everything supposed to be undo. That means, with a little bit problem, we have to recover the whole transaction and come back to the first state, which always is not acceptable. We have to have alternative solutions. That's omitted result. But partial result, during the lifetime of transaction, we need definitely some sort of collaboration with another transaction or releasing some result to another transaction. Based on ACID properties, isolation, we don't have that right. That's why applying ACID properties in service-oriented computing, it's problematic. Okay. Now, I'm going to talk about standard frameworks and challenges of each of these frameworks. Okay, the first one, of course, was Jim Gray model, the ACID one. Later on, Jim Gray has moved from IBM, and the last place he was in was somewhere in Microsoft. He relaxed ACID properties for having some sort of middle solution. But later on, Elliot J. Moss has introduced nested transactions. He tried to make some sort of tree structure for transaction and make them give them that ability for coping with long life transactions. Of course, that had some problem too, because sometimes these results or these data are not just inside of transaction. As we talked about partial results, we have to release them for outsider, for other transaction outside of that particular transactions. The third important classical extension of transactional model was sagas and its sagas. It's very famous. It has linear structure, and it works based on some sort of compensation. We have, for each transaction, we have the reverse transaction that can be compensated on the reverse order. In literature of transactions, we have lots of theoretical model for solving this sort of problem. I'm not going to go through details of all of them, just in high level I will mention them and with a brief explanation. For finding more information about them, there are lots of literature and you can study them on the internet. There is extended sagas that can try at least to solve the classical problem of sagas. Sagas is a great model, but it is linear. That means it has real limitation. Meanwhile, it doesn't allow partial results. Then we have multi-level transactional model. It introduces virtual consistency graph. It's some sort of consistency graph for releasing data between sub-transactions in a nested environment, and it has some interesting deadlock control mechanism. We have contract transactional model, it works based on the contingency transactions, which means it can provide alternative scenarios. This model solved the omitted result problem, and it has the compensation concept inside of itself. That means you can compensate some part of transaction and come back in the middle of transaction. You don't need to come back to the first step. You have a split transactional model. It's very interesting theoretical model. It works based on serialization theory. It's nice if you check it. It has its own recoverability model. We have the flex transactional model. It introduces internal and external dependencies, and it provides facilities for sharing results between two uncommitted transactions, two unfinished transactions. And then we have cooperative transactional model. Again, it solved the partial result problem. Introduced new concurrency control for those concurrent transactions. We have coordinating transactional model. It's excellent model for collaboration, especially. We have mega transactional model. Provide a scheduler system, and you have concept of conditional commit and compensation mechanism for itself. And we have famous DOM transactional model, which probably you've heard about it, and it's quite big, but again, not exactly in context of our talk. Okay, very simple triangle of service orientation that probably you are familiar with it. Of course, this is mostly the conventional SOA, conventional service-oriented computing. You have service provider, service requester, and repository, which the famous one for describing the service, you have WSDL, you have UDDI for service repository, and for talking these service providers, you have SOAP message protocol. I go a little bit deeper on service-oriented computing. The most important part of service-oriented computing that I want to repeat it, probably you know it, but I want to make sure we apply it, is this concept. Probably you've heard about service composition, and you know that with WSDL you can describe your services. But what is very important is this border. Normally, when we talk about service composition, WSDL, all of these specifications, we are talking about this part of the border, service deployment level. This shouldn't be coupled with the actual implementation. Theoretically, you can implement any languages. Practically, it should be you should have this possibility for having service composition on top level. You create just WSDL and bang, you can have your service composition, you can do everything, you can register your service, description of your service in a repository like UDDI and do everything. Therefore, any sort of protocol in service-oriented computing should consider these important